My name is Alex Forstedt. I am part of the co-authors of ERC-437, and right now I'm working on RIP 7560 and related RIPs that are related to full native account abstraction for Ethereum. RIP stands for Rollup Improvement Proposal. So as we started working on account abstraction natively, we realized that there is no process to formally introduce and standardize changes to EVM on layer 2s. So as you know, changes to Ethereum mainnet, they are done through the process called EAP, Ethereum Improvement Proposal. And changes that are not protocol are made through ERCs, Ethereum Requests for Comments. But there was a missing part for coordinating changes between multiple EVM-compatible layer 2s, and each one was doing their own thing, and it could lead to future incompatibilities. So the EF started this third process, so that was added to the EAP project, and now there are multiple layer 2s that are participating in this organizational event. So some examples also for RIPs that exist are 7212, if I remember correctly, that introduces a ECP 256R1 precompile to verify signatures, and it has become in EAP lately, so RIPs that become mature enough to be introduced to Ethereum mainnet can become EAPs. This is the next step in our journey to full native account abstraction across the EVM. What it mostly does, it fully enshrines the design decisions we made in ERC-437 as part of the EVM, as part of the protocol, and it's aimed for layer 2s. That is why it's part of the RIP process. And it makes the entities that we defined with account abstraction native parts of the consensus protocol. So paymasters, factories, smart accounts, and validation frames specifically become parts of the protocol that adopts RIP 7560. And in this way, the chain that adopts it does gain a full native account abstraction, meaning if they want to, they can stop supporting EOAs, or they can even start without ever having EOAs, and have transactions that are validated by RIP 7560 protocol. Right, so it's important to understand that ERC-4337 have become reasonably complex over the years. It has been evolving, and not all design decisions that we made there are equally crucial and important for full native account abstraction. And some of them do add some extra quality of life improvements. When changing it from ERC to RIP, we decided to split it into parts that layer 2s choose to implement or not based on their personal preference. There is a number of components. The main one is RIP 7560. This is a core specification for account abstraction. It introduces the concepts of paymasters and smart accounts and validation and execution separation. There is also ERC 7562. This is where we define the validation rules, because in account abstraction, the validation code has to be sandboxed, which means that not every opcode and not every storage slot that exists is available to the code running in this frame. RIP 711. This RIP is designed to make account abstraction more friendly for layer 2s or networks that have decentralized permissionless mempools, which mean that all validation frames of account abstracted transactions need to be executed in a separate block space to allow parallelized validation of transactions. There are other less critical, I would say at this moment, but also important for future feature parity with ERC-4337, such as in our design, nonce has become a 256-bit field, and the first 192 bits are used as a sequence, allowing parallel execution of transactions. So if an account has multiple operators, they can operate in parallel, and that is what we introduced in RIP 7712. And we are also working right now on signature aggregation RIP that would allow multiple transactions to share a single signature, which would save a lot of call data and computation on chain. Since the type transaction envelope has been introduced in Ethereum, the preferred way to introduce new features to Ethereum was usually through a new transaction type. And that is exactly what we did. We introduced a new transaction type that is very similar to user operation as it was defined in ERC 4367, but it is now a native part of the protocol. It adds such fields to a transaction as paymaster, factory, and gas limits for the validation frame, execution frame, and it does separate the validation and execution. So the important part here is the validity of this transaction is no longer defined by the protocol. Legacy transaction types, all of them that exist right now, their validity is checked by the protocol. When the protocol checks the balance, nonce, gas fee of the transaction and verifies the signature. Now this is removed, and a dedicated smart contract, that is your smart account, will perform the validation. The validity of your transaction fully depends on the execution of this validation code. This is not the same as reverting a transaction on-chain, as can already be done, because when transaction reverts on-chain, it has been included in a block, and the sender of this transaction has been charged for gas. With RIP 7560, the transaction is not valid until it passed the validation. So in, for example, ERC 4337, an invalid transaction can, and sometimes they do, get on-chain, and they do revert, and they cause losses for the bundle. It's not something that's possible with native account abstraction. Everybody in the community who is interested in this RIP or adjacent RIPs should first of all get in touch with the team. We are available on multiple platforms, Twitter, Discord, Telegram, Ethereum Magicians, GitHub, and we are very open to all kinds of contributions, help, feedback on our design. The specific call to action to the developers who are working on a new kind of layer 2 or maybe alternative layer 1 networks to get in touch, to provide feedback, to start building, see the code that we have already written about this RIP, and yeah, let's build it.